Hello, folks. So our goal here is to write the area of the triangle as a function of x. So a as a function of x. Now, we know that the formula for the area of a triangle is 1/2 base times height. All right, so this would be our base, and this dimension would be our height. And we need to get b and h in terms of the variable x. All right, so now we do have two coordinates here. We know that this coordinate here is x comma 0, which means that the distance along the x-axis is referred to as x. So hence, b is equal to x. So I can make a substitution there. So b is equal to x. So I have a is equal to 1/2 x times. Now in the other dimension, you have that this distance has to be y, because we're told that the y-intercept we're defining as 0 comma y. And so therefore, h let's try that again using the highlighter tool. H here is going to be equal to a value of y. So we're a little bit of a step in the right direction. So I now have area in terms of x and y. And so now I just have to relate the variable y in terms of x. In other words, I have to find an additional equation that gets y in terms of x, so I can make a substitution. All right, so I'm going to go ahead and write the slope between the top 2 points. So the slope between these two. So that would be y minus 1 over 0 minus 2. And I was very specific about choosing the y variable first, because then I don't have to deal with negative signs in front of variables. I'm going to then find the slope between the next 2 points, between these 2 points here, and that slope is going to be 0 minus 1 over x minus 2. And since we have a linear function, those two slopes need to be the same. So I need to set them equal to each other. So therefore, y minus 1 over negative 2 needs to be equal to negative 1 over x minus 2. Now, remembering that our goal is to solve for y and make a substitution, I am going to, let's get rid of the negative 2 in the denominator here. I'm going to multiply both sides by 2, negative 2 I should say. So multiply both sides by negative 2, and therefore I get y minus 1 equals a positive 2 upstairs. So positive 2 over x minus 2. And therefore y equals, now I'm going to add 1 to both sides. All right, and so if I'm going to try to add those two things, I need to try to get a common denominator. And so a common denominator would be, I'm going to multiply the 1 by x minus 2 over x minus 2. So therefore, let me scooch this up just a smidge. That would give me y equals, and my common denominator is x minus 2. And in the numerator, I have 2 plus x minus 2. Therefore, giving me y equals x over x minus 2. Now, this is my second equation that I needed in order to make a substitution up into my area formula. So now I have area as a function of x is equal to 1/2 x times x over x minus 2. When I multiply that out, a of x is equal to 1/2 x squared over x minus 2. Now, if we're talking about domain, since I have a fraction here, we need to think about values of x that would make the denominator 0, therefore making the overall fraction undefined. And so, therefore, we would say, in terms of our domain here, we would know that x could not be equal to 2, most certainly, because it would make the denominator undefined. But let's go back to the context for just a second. So one thing that we know about areas is that the area of the triangle needs to be positive. Well, in looking at our overall area function, 1/2 is positive. X squared will always be positive, and therefore, in order to get an overall area result of positive, we need to make sure that we are taking a positive numerator here, because x squared will always be positive. And in order for this denominator to, first of all, not be 0, and also at the same time to produce a positive, so that way we have a positive divided by a positive, which will overall produce a positive area. What that means is that x has to be greater than a value of 2 in order for us to have a positive area amount.